Good morning, all. Myself, Sudharani. Today, I came up with new topic: stemming and lemmatization in information retrieval system. As I discussed in the previous video, I discussed about the text pre-processing and different techniques in the text pre-processing. As I said, for text pre-processing, one of the important steps are stemming and lemmatization. Stemming, what is the stemming and what is the lemmatization and what are the differences between the stemming and lemmatization. As I said, that I will discuss clearly in my next video. So today I came up with the topic stemming and lemmatization and the difference between stemming and the lemmatization. Stemming is the process of getting the root form of a word. Stem or root is a part to which inflectional affixes, it is, the, s, etc. are added. Let me explain by using some example. Say, for example, if you take any word like running, run, ran. So all these words are called as. We can take another example. We can take another example. Comfortable, comfort, comfort, uncomfort, comfort. Okay. So whatever the words we are taking, this all words are called as the stem words. And for every stem word, we are having one particular root word. For running, run, ran, run away, all these stemming words, we are having one root word. Here it is called as run. Run is the root word for the stemming words. And if you take this, for these all stemming words, we are having the root word as comfort. You can take any kind of example. Talking, talk, talk. For this, we are having root word as talk. Walk, walk, walk. Like this. For this, we are having the root word as walk. So now come back again to the definition. What is a stemming? Stemming is a process of the root form of a word. See here, running, it is here, it is added ing. Here, comfortable, able, talked, ed. Again, talking, ing, walking, ing, walked, ed. So here, stem or root is a part which inflectional affixes id, is, id, etc. are added. So to the root word, some ending will be added and it will convert to the stem word. So the stemming procedure is where to find out the root word from the stem word. Whatever the stem words we are having, we are converting the stem words to the root word. Whatever the stem words we are giving, the stem word has to be converted to its root word. Next, if you take this example, studied, studying, study, studies. Okay, so this all are suffixes with this all are suffixes with some extension. Here if you see id, again ing, again is. So this all are added with some extension to the root word. So whenever the suffixes are added with some is, aid, ink, such kind of words, then it is called as what stem word. Now this all are called as the stem word. Then what will be the root word? What will be the root word for these stem words? So study. Study is the root word for this stem word. Study is the root word for this stem word. So stemming is a process of getting root from a word. So stemming is a process where we are generating the root word from the given stem word. I will also tell what is the necessary to convert the stem word into the root word in text pre-processing. The stem of a word is created by removing prefix or suffix of a word. See here we seen only suffixes, but in some words we are having the stem word can also be generated with prefixes also. If you see comfort, see here it is prefix. Comfortable, it is suffix. Uncomfort, it is a prefix. So some words are there. Misunderstanding. Misunderstanding, if you see, misunderstanding is a stemming word. And what is the root word for the misunderstanding? Understand. Understand is a root word for the word misunderstanding. So if you see the stem word, definitely misunderstanding is a stem word for root word of understand. If you see this stem word, here we are having both prefix and the suffix. Suffix we are having ing, as well as prefix we are having miss. Prefix we are having miss and suffix we are having ing. So the root words, the stem of a word is created by removing prefix or suffix of a word. If you take here the stem word, we have to this stem word we have to remove both prefix as well as the suffix to generate the root word. Stemming is a process of reducing a word to its word stem that affixes to suffixes and prefixes or to the root of is known as lemma. So we will discuss lemma separately. Now let us concentrate on the stemming only. Stemming is important in natural language understanding, NLU, and natural language pre-processing. Stemming is one of, first of all, text pre-processing is main in information retrieval system or NLP, natural language processing also. So in the stemming, in the text pre-processing, stemming is one of the method. And stemming is very important method in text pre-processing. I will tell why the text stemming is important and what is necessary to convert the stemming word to the root word. Stemming is a part of linguistic studies in morphology and artificial intelligence information retrieval and extraction. Stemming and AI knowledge extracts meaningful information from vast sources like big data or the internet since additional form of a word related to a subject many need to be searched to get the best results. I will tell this point with by taking the live example. Let us take. So as we discussed here, stemming and AI knowledge extract meaningful information from vast sources like big data or the internet. So why we have to do the stemming, or why we have to convert the stem word to its root word? Now let us take latest. Take one example. Latest article on computer studying. See here, this is studying. Just now we discussed study, studied, studies. These all are what? Stemming words. If I give one query like in search engine, like latest article, I am understanding that this is the wrong way to give the query, but I will tell you why we should not give like this. Latest article and computer studying. See here, what are the information to extract we got. See, I given the query as latest article and computer studying. Now convert this into its. Now this is a STEM word where studying is a STEM word. Now convert it to just study. Now see, given its root word, not the stemming word. Latest article on computer study. I given the root word. See here, you are getting lot of articles. You are getting lot of articles. What I want to tell means, instead of giving the, if you are giving the stem word, then the searching will be complicated. Why? Because stem word may be multiple. Stem word may be multiple. So searching of multiple sources may be complicated and the search results will be less. Whereas searching with the root word, we used to the quickness of the search engines will be increased and matching of the sources will be increased. So that's why in text processing, stemming is very important way to convert the stem word to its root word. So this is the point. Stemming is also a part of queries and internet search engines. Recognizing, searching and retrieving more forms of words, return more results. When a form of a word is recognized, it can make it possible to return search results then that otherwise might have been missed. Without stemming, if you are searching for the word, what happened? It may not give the exact results. We can see here. See, again I'm typing as studying. Where it is the stem word. Generalized information, we got the generalized information. Because we are giving the stem word where the searching will be complicated, exact results may not be given. So see, if I am giving the root word means exact word which you want to search for. If you are giving that, much probability is there for the searching result. That additional information retrieved is why stemming is integral to such queries and information retrieval. So we've seen the definition of stemming. Now let us see the types of stemmings. Porter's stemming algorithm. Porter's stemming algorithm. Common algorithm for stemming in English. So Porter is the generalized or the common stemming algorithm where we used for the, as I said from my last video, I said that again I'm repeating, stemming is not only for English language. Stemming can be applicable for any other languages also. We can also use for our local languages like Telugu, Hindi, English, any kind of language we can apply the stemming. And general English stemming algorithm, we use the Porter stemming algorithm. The algorithm consists of 5 sets of rules applied in order, phases applied sequentially. Each phase consists of a set of commands. Simple conventions of rules in a compound command, select one that applies to the longest suffix. So the point we have to remember here is first type of stemming algorithm is a Porter stemming algorithm, which is a default one where we are using in the English language. So Porter stemmer. Here we are having both constants and the vowels. We are having both constants and the vowels. So it will take constants. As we all know what is the constants. Consonants, we all know what are the consonants. A, E, I, O, U, and vowels. The remaining letters are the vowels. With this definition, all words are of the form. See here, we are having some formula for the Porter stemmer, how it is going to convert the stemming word to its root word. So we can see C, B, M. C stands for string of one or more consonants. String of one or more consonants means consonant plus. B, string of one or more vowels. So as we discussed, Porter stemmer, it is having both consonants and the vowels. So C indicates a string of one or more consonants. B indicates a string of one or more vowels. And M, measure of word or word part when represented in this form, VC. V into C, vowel and consonants. So what is a measure of words? For example, see here M equal to measure M. We've seen that M equal to what? Measure of word or word part when represented in this form VC. So we see M equal to here the measure M equal to 0. Why? Because here we see tree, tree by TR. So here we see measure of word or what part when represented in this form VC. We need to see what string of one or more words, consonants, string of one or more words, vowel. So here we don't have that combination. So M value equal to 0. Tree. When we see the tree, M value equal to 0. But see the second example, here we are having M equal to 1. Why? Because in the word table, we seen U, B. U is where consonants, that is C value. B is where vowels, that is V value. So here we got the formula like M equal to, this is in this form, VC form, M equal to in the VC form. So we are getting M equal to 1 in the word trouble, where we are having U and B, combination of consonants and the vowels. And again, you can see oats. In the oats also, we are having again the combination A, T. A is again consonants and the T is vowels. And you can see again trees, E and S. So like this, if you are having the combination of VC, then the measure is going to count the words. And see again another example, M equal to 2. Why? Because in the same word, we got the two combinations of VC, that is UB. This is troubles. UB we got first combination and ES we got the second combination. So this is C. Don't be we should not be confused. See, these are the different words. Every word we are getting one VC combination. So it means M equal to 1 only. So you may get a doubt. This trouble we are getting VC, oats we are getting VC, this we are getting VC. So M equal to 3. No. So in a word, the combination is repeating only once. So this is another word, this is another word. Combination is repeating. If you take the different words, the combination is repeating only once. So M equal to the value M equal to 1. But where we see M equal to 2, here in the trouble, we are having the same single word. The combination is repeating twice, where UB, LE, sorry, UB, ES. In the troubles, we are having UB one combination and ES one combination. So the value M equal to 2. And if you see private, IV, private IV, AT, again in a single word, the combination in the single word, the combination is repeating twice. So M value is 2. So like this, we have to take the M values. I hope the people understands now. So what is the C value, what is the B value, and what is the M value? How to calculate the measure of words. This is M is called as measure of words. Okay, done. So like this, the Porter stemmer, first it used to define every word. And then in the second step or the second one is rule for removing a suffix. So as we discussed from the previous slide, that stemming is the process of removing prefix or suffix from the given word to generate its root word. Either the prefix we can remove or the suffix we can remove, which is considered as an extension for its root word. So second rule is what? Rule for removing a suffix. So what rule we have to follow to remove the suffix? The rules are of form, see, condition S1 tends to S2. Condition S1 tends to S2. Means where S1 and S2 are suffixes. The rule are of the form condition S1 tends to S2, where S1 and S2 are suffixes. This means that if a word ends with a suffix X1 and the stem before S1 satisfy the given condition, then S1 is replaced with S2. We will take one example. EMENT. So here if you take, if rule is greater than 1, see EMENT. In this S1 is EMENT, you can consider as S1 and S2 is null. So this would map replacement to replace. This would map replacement to replace. So if you take S1 EMENT and S2 is null, means if you replace with null, also there is no problem. So you are getting the root word as replace. So this is the condition, means if you are removing S1, then the remaining part should be root word. In that case, you can remove the suffix. This is a rule for removing the suffix. Okay. Again, rule for removing suffix. The condition part may also contain the following. The condition part may also contain the following. M, measure of stem. Just now we discussed how to calculate the measure of stem. The stem ends with S. V, the stem contains a oval. D, the stem ends with the double constants SSTT. O, the stem ends in CVO. Second C, not WX or Y. Example, WILHOP. The condition part may also contains expressions with and, or, and not. Let's see, Porter stemmer. Now we see in the rules. Step 1. See, SSES tends to SS. So just now we seen S1 tends to S2. See the example, careers. CARESSES, careers. It has to replace with S2. S1, if we take SSES as the S1, has to replace with S2. CARESS, careers. So there is no loss, and it can be considered as what? Root word. So this is a stem word and it can be considered as root word. This is first scenario. The second one, IES tends to I. Again, IES tends to I. IES is replaced with I. Ponies, PONIES, ponies. IES is replaced with I. Pony. Ice, TIES tends to tie. WS tends to WS. Carrots tends to carrots. See here, S tends to E. Cats. Cats. Or S tends to null. Cats tends to cat. So like this, we are able to identify the stemming word and the root words in the step 1. Step 1A, that is step 1B now. M should be greater than 1. M should be greater than 1. See, WED tends to WE. Condition verified. Agreed. Agreed tends to agree. Condition not verified. Feed tends to feed. What I said, M should be greater than 1. The condition has to satisfy. Double ED tends to double E. M is greater than 1. Double ED tends to double E. Here, agree tends to agree. M is greater than 1, so condition is satisfied. But where if you say feed tends to feed, M equal to M equal to 1, so it is not satisfied. The condition is not satisfied. Take the next scenario. ED tends to null. Plastered, plastered tends to plaster, means ED is replaced with null. ED is replaced with null value, that is 0, not replacing with any value. So plaster tends to plaster. So here ED is replaced with null. So the value is only plaster. This is satisfied condition. Bled tends to bled. Bleed tends to bleed. Then here it is not, because this is null. You are not replacing any value with anyone. So both are equal. So the condition is not satisfied. ING tends to null again. Ing tends to null again. We see lot of examples with ending with the ing. Motoring. ING is replaced with null. If you remove ING, then the base word is, or the root word is motor. Sing, SING, sing tends to sing. Here ING is not replacing. ING is not replacing with null. So the condition is not verified. Just now we discussed. Now, the Porter stemmer cleanup. These rules are ran if second or third rule in 1B applies. These rules are ran if second or third rule in 1B apply. See, AT is replaced with ATE, AT is replaced with ATE. Conflated tends to conflate. Here ED it tends to ATE, ED tends to ADE, BL tends to BLE, troubling tends to trouble. So Porter stemmer step 3 and 4. Here we are having derivational morphology. See, M is greater than 0. ICAT tends to IC. Example, triplicate. We can see the suffix ICAT, triplicate, tends to triplicate. So this condition is satisfied. Why? Because it is ICAT is replacing with IC. So the condition is satisfied. Next, M is greater than 0. FUL tends to E. FUL tends to null. FUL tends to null. See here, hopeful, joyful, hopeful. So FUL is replaced with null. So condition is satisfied. M is greater than 0. NESS, NESS, NESS tends to null. Goodness, NESS tends to null. Goodness tends to good. Here also the condition is satisfied. This is step 3, derivational morphology 2. In the step 4, see derivational morphology 3. Derivational morphology 3. M is greater than 0. A and C tends to null. A and C tends to null. C. 11s tends to low. So A and CE is replaced with null. 11s tends to allow. E and T tends to null. C. Dependent tends to depend. So E and T is replacing with null. So condition is satisfied. Next, IVE tends to null. Effect 2. IVE tends to effect. These are Porter stemmer step 3 and 4, where step 3 is the derivational morphology 2. Step 4 is the derivational morphology 3. So come to the Porter stemmer step 5. Step 5A, E tends to null. See, M is greater than 1. E tends to null. See the example. Probate tends to probate, BAT tends to BAT. The condition is satisfied. E is replacing with null. NESS tends to null. M equal to 1 and I asterisk 0. NESS tends to null. See, goodness, NESS tends to null. Goodness tends to good. Next, step 5B. M is greater than 1 and D and L. Single letter. Control. 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 ROLL means it is replacing with only one L. Replacing with single L. CONTROL. Control is replacing, double L is replacing only with one L. Here the condition is satisfied. But if you see the second one, condition not verified, where ROLL tends to ROLL. So here double L has to be replaced with single L. So the condition is not satisfied. So this is the step 5 of Porter stemmer. Now we can see various stemming algorithms. We can see various stemming algorithms. Porter stemmer, as we discussed now, Porter stemmer, Lancaster stemmer, REGEXP, regular expression stemmer, snowball stemmer. These are the few of different types of stemming algorithms we are used in the NLP or the information retrieval system. So as we discussed just now, we completed what is the Porter stemmer. So to use the Porter stemmer, first we need to import the natural language toolkit NLTK. This is importing the NLTK is a default thing in Python programming to perform the NLP programs. From NLTK.stem, import Porter stemmer. Next, create an instance of Porter stemmer class as follows. We can create the instance of Porter stemmer like word stemmer equal to Porter stemmer. Put what you want to stem. It's a very simple C. What stemmer dot stem of writing. So we seen as writing, write, wrote. So all this, the stemming words, root word is what? Write. So simple stemming in the NL stemming by using NLTK toolkit is very simple. Simply we have to use import the NLTK toolkit, and we are creating one instance for the pot stemmer. So where for this instance we are using the word, whatever the word you want to generate the root word, that stem word we have to use here. Writing. So if in the same, if you use talking, what stemmer dot stem talking, if you give the input as talking, the output is generally generated as talk. Walking, walk. Comfortable, output is comfort, like that. So by using the Potter stemmer, as we discussed, the Potter stemmer is the default stemming. Default stemming we are used in the English language. So the Potter stemmer, by using the Potter stemmer, the root word is going to be generated. This is a simple example. Next one, Lancaster stemming. So all Lancaster stemming. NLTK has Lancaster stemmer class, with the help of which we can easily implement Lancaster stemming algorithm for the word we want to stem. Say we have to import NLTK toolkit and create one instance. Here, LNC stemmer equal to Lancaster stemmer. And if you give the word eats, EATH eats, then what will be the output of root word? Eat is the output of root word. So here the stem word is eats, and we have to generate the root word. Root word is eat, EAT. Next one is regular REGEXP stemming algorithm, that is regular expression stemming algorithm. With the help of this stemming algorithm, we can construct our own stemmer. Just like it is hybrid method, where we can use our own stemming, not using the default thing or the predefined one, where it is we can customize. We can customize our own stemming things. NLTK has regular expression stemmer class, with the help of which we can easily implement regular expression stemmer algorithm. It basically takes a single regular expression and removes any prefix and suffix that can match the expression. So again, for the regular expression also, we have to import the NLTK toolkit, and after importing the NLTK toolkit, create one instance. So here, REG stemmer is the instant equal to regular expression stemmer, and here we are giving the word as in gate, in ing EAT. Here we am. This is not the meaningful word, but just to show the results, I'm using ing EAT. Here, suffix is not there, so it is having the prefix. So it will remove the prefix, and it will generate the root word as output as eat. Output as eat. If you in reverse, if you write like eat, if you in reverse, if you write like eat, this is suffix. This is a prefix, this is a suffix. If you give suffix also, it will generate whatever a prefix or suffix, it will remove, and it will simply generate the root word as eat. This is the regular expression stemming. Last type is snowball stemming algorithm. Snowball, it is another very useful stemming algorithm. Snowball stemmer class. NLTK has snowball stemmer class, with the help of which we can easily implement snowball stemmer algorithm. It supports 15 non-English languages. See, I said so many times that stemming is not only meant for English, and stemming can be applicable for any local languages or any another languages which we want to generate the root word. So snowball stemming can be applicable. It supports 50 non-English languages. So for the English languages, Porter is the default one. See, first type is the Porter stemming algorithm. So Porter is default thing which we are using when we are using the English language. And landscape, next one before Lancaster. Second one is a Lancaster. So Lancaster, we can use our own Lancaster. We can use with any type of the English words, and we can remove the suffix as well as the prefix. And next one is a regular expression. So in the regular expression, we can customize the stemming word. We can give our own. See here, if you see ing is the my own customized word where I added prefix to the word, and it is my own customized word. There is no particular meaning, but also I can stem the word to its root word. So this customization can be happened in the regular expression stemming algorithm. And snowball can support 15 non-English languages. In order to use this stemming class, we need to create an instance with the name of the language we are using and then call the stem method. So first we have to define the language which I'm using. Either I'm using Telugu, I'm using English, I'm using Hindi, like that. First I have to define the language, then I can import the NLTK toolkit. So see here, import NLTK. Here I'm giving. So this is creating instance. RENCS stemmer equal to snowball stemmer. See here, I'm defining the language as French. I'm defining the language as French. So after defining the language, I can give the word, whatever the word I want to give. So this is the small explanation regarding the stemming. I hope all people you understand. Now let us move to, as I said, I will discuss about the stemming and lemmatization both, and the differences between the stemming and lemmatization. Now let us move to the lemmatization. Done. Now come to the part lemmatization. Process of grouping. If you see my previous video, text pre-processing, you will understand what is the difference between the stemming and lemmatization. Here one more time, I am trying to explain clearly with some examples. Now, lemmatization, process of grouping together the inflected forms of a word to be analyzed as a single root word or lemma. Here in the stemming, we call it as stem word and the root word. Here we used to call it as a lemma and the root word. Unlike stemming, lemma reduces the inflected words, properly ensuring that the root word belongs to the language. Here we have to remember only one major point regarding the stemming and lemmatization, that stemming, it doesn't check the generated root word is having the meaningful word or not. It won't concentrate on the rules and regulations of the language. Its task is only to generate the root word. Either the root word generated is correct or not, also it doesn't matter. But whereas in the lemmatization, whatever the root word it is generating, it ensures that the root word is having a proper meaning and it is belong to proper language. That is a major difference between the stemming and the lemmatization. See here, bowl, bowling, bowled. These are the lemma, and if you see the root word, bowl is a root word, and if you see this, it will be same like stemming only. In the process of assembling the inflected parts of a word, such that they can be recognized as a single element, call the word's lemma or its vocabulary form. This process is same as stemming, but it adds meaning to a particular word. In simple word, it connects text with a like meaning of a single word. It is defined as an algorithm technique of finding the lemma of a word in which is a root word rather than the root stem. It is based on intended meaning the word is trying to convey. See here example rocks. Root word is rock. Corpora, corpus, better, good. If you see rocks, we are simply removing the suffix and we are generating the root word. Corpus, corpora, we are replacing O R A with US. It's fine. We are generating the root word. But if you see better, Better. See here. Better is having Better. So according to the stemming, if you either to remove the suffix or the prefix to generate the root word. In the word better, can I have any prefix or the suffix? For example, we don't have any prefix. If you think er is a suffix we are having, if I remove er, does it mean anything? Is the word is having anything? Or does it mean that I generated the root word from the stemming word? Definitely no. Definitely no. Means for the word better, there is no prefix and there is no suffix. Then if there is no prefix and there is no suffix, then how the word is going to be generate the root word? Means for better, the root word is obviously better only. There is no more root word. So if you give the better, it will generate the root word as better only. So that is related to stemming. But whereas for the lemma, see for the better, the lemma word, it is generating as good. It is generating as good means, see, according to the definition, so what is the lemmatization? The process is same as the stemming, but it adds meaning to particular word. In simple words, it connects text with alike meaning to a single word. Isn't it? So if you see this example, so better, for the better, it is giving the word as what? Good. Where, if according to the stemming, the better, good does not match. But according to the lemma, the better is having the lemma of what? Good. So very near or the meaningful word it is going to generate. Applications of lemmatization. So lemmatization it is used in biomedicine where nowadays the research scope for medical sciences is very huge. So used in biomedicines, processing of related biomedicines can be affected by using specialized lemmatizations and may increase the efficiency of data retrieval task. That I will show you one live examples. Take. Latest articles on what we have to give latest articles on computer science. See, I given as latest articles on computer science. Articles is my board, but it is generated papers, topics, features, right? So papers, topic, features are all related what? These all are related to articles where it is performing lemmatization. Means it is going to filter us the very nearest and the closest words which can be replaced with articles. I given like latest articles and computers, but you can see about topic features done. So this is called as the lemmatization where in the information retrieval system, the lemmatization is going to give us the much scope for the quick retrieval of information. So, used in comprehensive retrieval systems like search engines, just now we've seen. So, lemmatization is a process of converting a word to its base form. The difference between stemming and lemmatization is lemmatization considers the context and converts the word to its meaningful base form, whereas the stemming just removes the last few characters, often leading to incorrect meaning and spelling errors. So I said again and again, so stemming, its responsibility is only to convert the stemming word to its root word. And in the process of converting the stemming word to its root word, it doesn't check whether the generated root word is the meaningful. Does it have any meaning, or does it related to any language, or is it generated correct word? The spelling is correct. It doesn't follow all these things. It is the stemming. But whereas in the lemmatization, in the process of converting the word to its base form or the word to its root word, the generated root word should be with a proper meaning and should be with a proper spelling, and it should be belongs to particular language without any spelling mistakes, without any word mistake. And it should not break the lemmatization. It won't break the rules and regulations of the particular language. So where is the stemming, it doesn't matter, doesn't think about any rules and regulations of the language which we are using. So this is the difference between the stemming and the lemmatization. As we discussed, differences between stemming and lemmatization. So see here stemming, studies, the suffix is es. Stem word is what? S-T-U-D-I, study. It forms studying. In studying, the suffix is ing, and the stem word is stood. So based on the stem word, the root word is going to be changed. So the first studies, the root word is study. Studying, the root word is study. Both doesn't having any meaning. S-T-U-D-I, it doesn't have any proper meaning, and it is not the correct spelling. And studies also, it doesn't have any meaning. It is not the proper spelling. But whereas a lemmatization, see, if you check the lemmatization, studies, S-T-U-D-I-E-S, studies, and meaningful information equal to third person, singular number, present tense. So the lemma for the studying is study. Studies is for study. See, studies, we are getting for study, and studying. Studying, again we are getting lemma as study only. So this is the difference between the stemming and the lemmatization. So stemming, the root word may be different. The root word may be differs or changed based on the stem word. But whereas a lemmatization, whatever the words we are taking, the root word used to be constant and meaningful and with proper spelling. Which one is best? This is the most important question. Which one is best, and in which situations we have to choose lemmatization, and in which situations we have to choose stemming? Stemming versus lemmatization. See the word stemming. Change, changing, changes, change, changer. For this all, we are getting the stemming word as change. See, with the pronunciation, it is correct change. But if it comes to the spelling, it is like C-H-A-N-G, change. C-H-A-N-G, change. It is not correct meaning. It is not correct spelling. It doesn't belongs to any proper meaning. So this is a stemming. But whereas for the lemmatization, if you see same, whereas lemmatization, if you see same, change, changing, changes, changes, same, but the lemma will be change. C-H-A-N-G-E, change. C-H-A-N-G-E, change means where it is having the proper meaning, proper spelling, and it belongs to proper language, and it obey the rules and regulations of particular language. Here we can see some words to understand much better about the stemming and the lemmatization. Feet, stemming will be feet, lemmatization will be foot. Wolves, stemming wall, lemmatization wolf. Cats, both stemming and lemma cat. Talk, stemming talk, lemmatization talk. Stemming versus lemmatization. Stemming, set of rules for removing characters from words. Increased recalls at the expense of precision. Example, EN rule, removing trailing ing or AI. Lemmatization, complex set of approaches for producing the dictionary form of a word. Increased recalls without hurting precision. Uses context to disambiguate candidates. To implement lemmatization using the following Python packages. So we've seen for the stemming, what are the Porter stemmer, regular expression stemmer, snowball stemmer, what are the package, what are the NLTK toolkits we are importing, and same like for the lemmatization in the Python, what are the packages we are used. WordNet lemmatizer. So these are the different types of lemmatizers. WordNet lemmatizer, spicy lemmatizer, text bold, Phillips pattern, Stanford Core NLP, Gensim lemmatizer, tree tagger. Let us see one after another. WordNet lemmatizer with NLTK. WordNet is a large, freely, publicly available lexical database for the English language, aiming to establish structured semantic relationship between the words. So, WordNet is a default lemmatizer which we used in the NLTK toolkit. It offers lemmatization capabilities as well and is one of the earliest and most commonly used lemmatizers. As we said that the WordNet is the default or the most used lemmatizer in NLTK toolkit. NLTK offers an interface to it, but you have to download it first in order to use it. Follow the below instructions to install NLTK and download WordNet. WordNet is a publicly available lexical database for over 200 languages that provides semantic relationship between its words. It is one of the earliest and most commonly used lemmatizers technique. It is present in the analytical library in Python. So defaultly in NLTK libraries in Python programming languages. So we are having the lemmatizers. WordNet links words into semantic relationship. It groups synonyms in the form of synsets. Synsets, a group of data elements that are semantically equivalent. How to use. Download the NLTK package in your Anaconda prompt or terminal. Type pip, install NLTK. Now download WordNet from NLTK in your Python console. Do the following. First, import NLTK. NLTK.download WordNet. NLTK.download average perception tagger. See, we can see here it will be like this. WordNet lemmatizer, as we discussed, WordNet lemmatizer is a default lemmatizer which can support 200 plus languages in the Python programming language. NLTK toolkits, it's the default one we are having. And see, NLTK.download WordNet from NLTK stem import. Create WordNet lemmatizer of WNL equal to WordNet lemmatizer. Single word lemmatizer examples. List 1, see here, kites, babies, dogs, flying, smiling, driving, died, tried, feet. For all these words, now I want to generate root word by using the lemmatizer. Now see, for the words in the list, print words. Here, what we are getting, kites. Kites is the word. Now we are generating the root word or the base word by using the lemmatization. Kites, we got kite, babies, baby, dogs, dog, smiling, smiling, driving, driving, died, died, fried, fried, feet, food. So these are some of the examples of lemmatizations. It's very easy and simple to perform the lemmatization in the Python programming language. Why? Because it is having the NLTK toolkit, where it is having the different methods. These are the single word lemmatizer. Now let us see the sentence lemmatization. Sentence lemmatization. See, if we take the string, the cat is sitting with the bats on the stripped mat under many flying geese. This is a string. So the complete sentence has to be generated to its root word by using the WordNet lemmatizer. The converting string into tokens first before, if you take sentence, then tokenization has to be applied. If you take multiple sentence, then sentence tokenization has to be applied. Or if you take single sentence, then word tokenization has to be applied. As it is a single sentence, now we are applying the word tokenization. Tokenization is already discussed in the text pre-processing techniques. A tokenization is a method which is used to divide the sentence into the single word. See, this is a sentence where the cat is sitting with the bats on the stripped mat under many flying geese. This sentence, before going to apply the lemmatization, first we have to apply the tokenization. See, tokenization, we have to divide every word. See, the cat is sitting with the bats on the stripped mat under many flying geese. Like this, every single word is going to be divided. The sentence is completely divided into single word. Now, after applying the tokenization, now let us do the lemmatization. Lemmatized string equal to join lemmatized word for words list for in list 2. First list 1 we taken the sentence, in the list 2 we are taking the tokenized word. Then the lemmatized string is, we got like the cat is sitting with the bats. Now see, you can see the difference between the input and the output. In the output we generated the root words. The cat is converted to cat, sitting, bats is converted to bat, strip, mat, flying, geese is converted to goose. So this is lemmatization. So a WordNet lemmatizer with POS tag is also there. So with the POS tag, we can see the simple examples. Driving plus where V tends to drive. What is for driving? Verb is V. This is called as POS parts of speech tag. POS is parts of speech tags. With the parts of speech tag also, POS tag also, we can do the lemmatization. The driving place where V tends to drive. Dogs plus noun. So in the POS, first we have to identify the tag, POS tag, either it is a verb or noun like that. Tags plus noun tends to dog. Dogs plus noun tends to dog. Next type is text bold lemmatizer. Text bold is a Python library used for pre-processing textual data. It provides a simple API to access its methods and perform basic NLP tasks. Text bowl, from text bowl, import text bowl word, my word. Now here the word we are taking as cats. Create a word object, W equal to word, my word. Perform the lemmatization. Sentence equal to C. Again, we are taking the sentence. The cats saw the cats. The bats saw the cats with strips hanging upside down by their feet. S equal to text bowl. Here we are using the text bowl lemmatization. Text bowl sentence. Lemmatized sentence equal to. Here we are getting the output C. The bats is convert to bat. Saw. Cats convert to cat. Strip, hanging, upside, down by their feet. It is convert to foot. So here these are few of the different types of lemmatizations. Again, let us see. We have to clearly understand in today's class we discuss what is a stemming, what is a lemmatization, and what is the difference between the stemming and lemmatization, what are the different types of stemmers we are having, what are the different types of lemmatizations we are having, and in the NLTK, in the Python programming, to download the different stemmers, what are the different methods we are having, how to work on the NLTK toolkit in the Python programming, and how flexible it is, how easy it is, and same for the lemmatization, what are the different types of lemmatizations we are having, and in NLTK toolkit in the Python program, again, what are the different methods we have to use for the lemmatizations, and what are the purpose of different stemmers, what are the purpose of different lemmatizations. We seen all these things in today's class, and the main part I want to tell you again and again to understand or the identification of difference between the stemming and lemmatization. This is much important for any type of things. You have to identify the difference between the lemmatization and the stemming. This is very, very important. And again, once again, I am telling the difference between stemming and lemmatization. See here. See here, lemmatization is the process of converting a word to its base form. The difference between stemming and lemmatization is lemmatization considers the text and converts the word to its meaningful base form, whereas stemming just removes the last few characters, often leading to incorrect meaning and spelling errors again. So in a single word, if you want to define the stemming, difference between stemming and the lemmatization is, in the stemming, here we can see, in the stemming, the root word is depend on the stem word, and the root word may not be same for all the stem words. Root word may be different depending on the which kind of stem word it is having, and in the process of generating the root word from the stem word, the root word may be meaningless word, or the root word may be incorrect root word, or the root word may not belongs to any particular language. It doesn't have any meaning and it doesn't have any spelling. It is having the errors. So the rules, the duties of stemming is only to identify, only to generate the root word by removing prefix or suffix of the given stem word. That's it. After removing the prefix or the suffix, it doesn't check either the generated root word does it contains any meaningful or any proper spelling or not. Its duty is only to generate the root word from the stem word. Whereas the lemmatization, unlike the stemming, lemmatization, so whatever the word we are giving, the generated root word in the lemmatization will be same. If you see here, we've seen the different words like studies, studying. So for the studies and the studying, both we are getting the lemma as only study. So whatever the word we are taking, the base word, the generated base word or the root word will be same for any kind of lemmatization we are taking. And the main thing to remember about this lemmatization is the root word generated by using the lemmatization. The root word is considered. The root word belongs to any particular language. The root word belongs to any particular language, and the root word is having meaningful word, and the root word is having the it doesn't have any mistakes in spelling. It is having the meaning, and it belongs to a particular language, and it follows the rules and regulations of the particular language which we are using. So this is the clear difference between the stemming and the lemmatization. Hope you people understand. The lemmatization means generating the root word or the base words with the very close or the nearest words. If the particular word doesn't having any meaning also, it is going to generate with very nearest or the close words. So this is all about today's class. Hope people are understand today's class, and I will come up with some new topic in the next class.